Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a discussion about evolutionary architecture and in particular fitness function. Now, evolutionary architecture is quite a difficult topic to understand, and the reason is, at least I think there are two reasons for that. One of them is when you first start as a programmer, you have low level technical problems like how do I write this code in order to make this work and so on. And then you get to the point where you are a senior developer and you can write code that pretty much works and you understand the structure that work at the low level of the code, like design patterns, or even if you don't call them design patterns, that's basically what they are. Various code structures and how they work. But then what you do is you switch to a software architect role, and often the way you get pushed into the software architect role is because you are a good developer, you are moved into that and you expect software architecture to be about technical stuff. And it turns out that it's not only about technical stuff. It's actually about a socio-technical system. In order to be able to produce the architecture that is best fit for, let's say, a specific business problem, you also need to have the necessary social support. So this is why you have this socio-technical. You need to have teams that are up to a certain level and so on. So this is why it's a socio-technical system. And as an architect, you come to understand sooner or later that you need to figure out how to manage this socio-technical system. And this is the first challenge, understanding this part. The second problem with evolutionary architecture is because it happens in a very slow motion. Many people compare evolutionary architecture, which basically means directions in which the architecture is moving naturally on the pressure of business and basically the socio-technical system. And you can compare it with the way cities grow. So cities, in order to do city planning, what you need to do is to think in large blocks and how, if we do a specific zone of the city, if we allocate it for industry, what impact will that have in 50 years on the whole city, for example. And something similar happens with software architecture. And a recent, relatively recent idea is to use these fitness functions as a way of moving the architecture, allowing the architecture to evolve on the lines that you desire, which is kind of similar with zoning, right? If you zone a specific part of a city for a park or for habitation or for entertainment, you expect that zone to develop in a certain way and then to have effects on the adjacent zones and on the whole system. This is something quite similar with what happens with fitness functions. But you can also understand fitness functions on a lower or in a more simple way. You can understand fitness functions as we need these desirable characteristics for our architecture, and those are usually non-functional requirements like performance, scalability, security, elasticity, reliability, so on. There are many of these. And you have to figure out which are the most important ones for your architecture. And then figure out what you need to measure in order to maintain those requirements, those desirable characteristics at the needed level for your particular architecture. But in doing so, you eventually hit the socio-technical system. So it's not possible to just do it as a technical minded approach and forget about the ecosystem in which the architecture lives. It just will not work. Your architecture will move in various directions. And one of the most common arguments for that is Conway's law. Your architecture will naturally evolve across the lines of communication within the organization. So that's one of the main constraints that we know for architecture. So while we discuss fitness functions, you can think of those as the first level, which is, okay, we have these desirable characteristics, what we need to measure in order to maintain those characteristics. Or you can think of those in terms of evolution. Where do we want, what are the constraints that we set on our system so that it evolves in the desirable direction? These are the two ways in which you can think about fitness functions. So let's look a little bit. I have two articles here, and I think they are quite interesting. One of them is Understanding Fitness Functions in Software Architecture, a Medium article published by Israel Josue Para Rosales, I hope. In software architecture, fitness functions play a crucial role in assessing and guiding the design decisions to ensure that the resulting architecture meets the desired qualities and requirements. The fitness functions serve as a qualitative measure or metric used to evaluate how well a particular architectural design aligns with the desired system qualities, constraints, and objectives. It essentially assesses the fitness of the architecture in meeting specified criteria. Fitness functions serve as a powerful tool in the software architect's toolbox, enabling the systemic evaluation of architectural decisions. By incorporating quantifiable metrics and criteria, fitness functions contribute to the creation of robust, scalable, and maintainable software architectures that align with the goals and constraints of the project. Their application is integral to achieving a well-rounded and high-quality software system. So let's look a little bit of a few examples. Key components of fitness functions, quantifiable metrics, so you need to measure things. Although fitness function, you can also have qualitative fitness functions, but that's a more difficult topic. Response time, for example, that's a very common one for performance. So, response time actually, granularity extends to specific metrics like response time, ensuring that the architecture is not only performant but meets precise timing constraints under different scenarios. So this is one example. Objective criteria. So let's look at the objective decision-making framework. So quantitative assessment, trade-off analysis. It's very important to have a trade-off analysis in your architecture. All architecture has trade-offs. So you need to figure out what are the most important things for your particular architecture, for your particular system, and focus on those. You cannot focus on everything. And whenever you focus on one thing, in architecture, you need to make decisions with incomplete information, which means that you will have trade-offs anyway, and there's no perfect solution. So avoiding bias and objective benchmarks. Okay, so let's look at a few of these. Scalability. So fitness function is often about scalability. I think what you need to take into account is generally the big four: performance, scalability, reliability, and security, but you can go beyond that. So scalability. Fitness functions often address scalability concerns, ensuring that the architecture can handle an increasing load or user base effectively. I would say it depends on the architecture, right? This sounds like it's the author's experience is driven by specific systems. Security, you should have specific verification for your thread model. And then maintainability, things like early stage application, continuous evolution, deployment pipeline, scalable frameworks, and so on. So examples, yeah, right. This is one that this is the most interesting part, I think. Examples of fitness functions, real world application and use cases. A few of them. Response time, yeah, under specific various load conditions. Scalability, so how many users, how many requests does it support? Security and maintainability. And now let's look at a very interesting second article, which is from ThoughtWorks, and it's called Fitness Function Driven Development. Now let me go back a little bit actually to fitness functions, because I think we can do a bit better than the article did. When you talk about performance, one fitness function is response time. When you talk about scalability, you should have number of requests. And often scalability is related with performance, because what you actually need is the graph of response time versus number of requests. And I would like more teams to do that using simulations. You can probably do that pretty easily. Another thing could be infrastructure cost, particularly if you're using cloud. You can also map the infrastructure cost per number of requests, which means that you could also have like a median price per request, depending on where you are, and maybe a distribution. In terms of so scalability, reliability. For reliability, you have mean time to failure, mean time to recovery. These are two indicators that need to be discussed and measured and have targets for. Another one for reliability is the number nines. How many nines? How long can you afford your system to be offline, basically? And you have to be careful with that. And sometimes you need to think about variability between night and day, between days of the week and weekends, between summer and the rest of the year, and so on. So there's peak periods, there's down periods. So you need to consider, kind of map these and have indicators that match each of those. And for security, you need to make your thread model. And depending on your thread model, you might end up with a set of specific indicators. Like, let's say, we might take the normal or the typical threats, one of them being injection. Now, let's say you have the possibility of an injection attack, and then what you could have as a fitness function is at least one automated test per potential injection attack. Now, this would be again a metric that you can use in your fitness function. But then it depends a lot on the type of product, right? Because you might have products that are very distributed. For example, you could have, and I worked with teams that were developing devices that you place on telecom towers. And for those devices, you can have additional indicators like how often do they break down, how often do you need to upgrade, how often do you need maintenance for the device itself. So when you mix hardware and software, you might have additional fitness functions. And you see how these things can kind of come together in the social and technical part. You could also have a number of tests or test coverage on specific areas. For example, you could say, let's say we ignore UI, we ignore integration, but in the center of the system, the domain model, that can have 100% test coverage. And this is one potential fitness function. Okay, so let's look at this ThoughtWorks article. And this goes a little bit further, and very interestingly so. It's called Fitness Function Driven Development, written by Paula Paul and Rosemary Wang, published 11 January 2019, so a few years back. Test-driven development, or TDD, involves writing tests first, then developing the minimal code needed to pass the test. TDD is an established practice for feature development that can improve code quality and test coverage. What about other non-functional requirements such as scalability, reliability, observability, and other architectural entities? How do we ensure operability and resilience of features when they go to production? How can we encourage teams to build in these architectural standards just as test-driven development builds in code quality and test coverage? And they are saying, okay, what are fitness functions? And talk about evolution. How do we enable evolution? Architectural goals and constraints may all change independently of functional expectations. Fitness functions describe how close an architecture is to achieving an architectural aim. During test-driven development, we write tests to verify that features conform to desired business outcomes. With fitness function-driven development, we can also write tests that measure a system's alignment to architectural goals. And this applies to any architectural style, monolith, microservices, and so on. Okay, so, and they developed that into saying that, so think of architecture as a product having user journeys and start by gathering input from stakeholders in business, compliance, operations, security, infrastructure, and application development to understand the architectural attributes they consider most important to the success of the business. This is why you need to identify the architectural concerns, like the top things you need to pay attention to. These attributes often align with the architectural entities. After team members jot down their top 5 or 6 attributes, you group the results into common themes, such as resilience, operability, stability. Yeah, I mean, that's one way of doing that. You can also do it with analysis. Often you know part of it. You can also validate and so on. Examining those themes often uncovers potential conflicts or architectural trade-offs, often, almost every time. For example, goals for agility and flexibility may conflict with goals for stability and resiliency. Yeah, and another one that's very common, performance versus security. Usually when you introduce security, more security means more cryptography, more validation, which increases response time, so usually decreases performance, but that's okay, that's the game. We attempt to achieve stability by establishing control over change and creating gatekeepers, while innovation and agility are enabled by reducing barriers to change in order to minimize the chance of failure. Shifting the mindset to value mean time to recovery over mean time between failures and embracing constant change is a challenge. Evaluating stakeholder motivation and holistically prioritizing the qualities that are important to the organization is the first step in defining architectural fitness functions. I would say is the first step in figuring out good architecture, because if you don't have these right, you will not get to an architecture that matches the needs of the business. And the challenge here is, if you ask business people, product people, they will tell you everything is important. Performance is important, you know, stability is important, scalability is important. It's the job of the architect to figure out how to prioritize those things in a way that fits the business, I think. And it's a big responsibility, but it requires a unique mix of business understanding with technical parts, which architects are well placed to have. Okay. So you define based on those fitness functions. After collecting fitness functions, draft them into a testing framework. Ideally, fitness functions should describe the intent of the utility. It addresses it in terms of an objective metric that is meaningful to product teams or stakeholders. Monitoring critical qualities as fitness functions can help product teams avoid architectural drift and objectively measure technical debt. But where do these fitness functions reside, and how do they signal potential architectural drift? Creating the desired fitness function and including them in appropriate delivery pipelines communicates these metrics as an important aspect of enterprise architecture. Regular fitness function reviews can focus architectural efforts on meaningful and quantifiable outcomes. These reviews also help maintain important system quality attributes for production readiness. So basically what you should have is a way to measure those and review them as often as possible and have them included in your pipeline. And you can have that. So for performance testing, there are specific tools. For scalability, you can use performance testing tools. They can match the same thing. So you can do these things and measure and see the drift. What happens particularly in agile organizations is that every sprint you'll develop new features, and it's possible that some of these indicators, some of these fitness functions will drift. You might get, for example, higher response times. And if that happens, that's fine, but you need to revisit the code in the next sprint so that you optimize for that. And that's kind of the back and forth that happens. Okay, and then they discuss about a few types of fitness functions. One of them is code quality, and they have modifiability, manageability, adaptability. This set of fitness functions can serve as gatekeepers to prevent the promotion of unmaintainable or untested code to production. The example below demonstrates a fitness function that could be provided to a product team with the intent to write a code that allows it to pass, applying a test-driven development pattern to architectural fitness functions. So something like describe code quality do, it has test coverage above 90% do, expect quality.get test coverage to be greater than 0.9. It has maintainability rating of 0.1 or higher. Do expect quality get maintainability rating to be less than 0.1. Now the question is, I like how they put this without specifying where you get the information for. The test coverage is obviously something that you can publish, but maintainability rating, yeah, maybe it's also an indicator you can measure and publish someplace. And then this code would read from the indicator database information. The next one is resiliency. It has 3 categories: stability, resiliency, availability. And as you would expect, the test looks similar. You'd say describe resiliency, do describe new deployment. It has less than 1% error rate for new deployment. Expect new deployment.get error rate to be less than 0.01. Then network latency, and then network test transaction time to be less than 10 seconds. So, another area which has come to prominence lately, particularly for microservices or any large architectural, but I think mostly it's about microservices, observability, debuggability, and auditability. We want things to be observable, which means that we need to have metrics. So expect service has metrics to be true. Expect service has logs in aggregator to be true. This is a very small thing. It just expects the logs to be there. It doesn't say what should be in the logs. And sometimes you'll need to have additional things. I'm thinking, for example, at privacy, maybe you don't want to have names and email addresses in logs. This could be one example of negative fitness function, things that you, a constraint actually, things that you constrain in your code. Then performance is about scalability and stability, compliance about auditability, security. So for security, okay. Interesting. So they give us examples. Expect code only uses corporate libraries. All right. I guess that's something you could validate depending on the systems you use. Expect code has OWASP top 10 to not be true. This is a bit harder to do. How do you prove you don't have those? And okay, maybe you have an audit and you store in a database that you have none of the top 10, but I would go maybe further and expect some security tests for a specific topic, maybe. Expect code has secrets in code base to not be true. Yeah, that would be fine. Expect libraries have no CVEs. This would have been a bit more difficult a few years ago, but now I think there are APIs who give you that information. And container has no CVs, so you can actually extract this information. And then you have operability, manageability, operability, recoverability. So for example, expect service has README to be true. Yeah, that's a good one. Expect service has alerts to be true. Expect service has tracing IDs to be true, particularly useful for microservices. So in conclusion, architecture like business capability in infrastructure can be expressed in code through the use of appropriate fitness functions as demonstrated in the examples above. What are the benefits of expressing architecture through the code and driving development with fitness functions? First, fitness function-driven development objectively measures technical depth and drive code quality. Well, objective here is kind of a mixed bag. I mean, it would be nice to have a completely objective measure, but actually it's so and so. As a second effect, fitness function-driven development can inform coding choices for interfaces, events, and APIs related to downstream processes. Yes, normally we would have done this with guidelines, but if you have an automated way of verifying the guidelines, even better. Fitness function-driven development communicates architectural standards as code and empowers development teams to deliver features that are aligned with architectural goals. Just as users request feature changes, enterprise architects can request changes related to regulatory, technical, operations, or security concerns. Including these architectural concerns in build pipelines allow developer teams to build secure, compliant operational services suited to these changes and gain clarity into the utilities that are most important to the organization. So to recap, fitness functions are about setting the right constraints and the right incentives so that the architecture evolves in the right way. And they take into account the fact that architecture is a socio-technical system. It's not only technical, we need to take into account the whole ecosystem. And they are also very contextual to your specific product. You cannot copy them from another place. You need to figure out what's really important for your specific product within your specific context. This is why it's also quite difficult to identify the right ones, and probably you will need to do some iterations together. But if you manage to get them encoded, it allows you to monitor these fitness parameters in a way that goes beyond just having guidelines and reviewing the architecture every now and then. It's even better. It also communicates better to developers what is required in terms of architectural concerns from the code that they are writing. So I think overall this is a very interesting idea. I don't think many teams are using, and I think more teams should be using it, but more teams should be using test-driven development as well, which is a related concept, or least acceptance test-driven development. But if you are interested in those topics, we have more videos. And if you are interested in architecture, we have a whole playlist on software architecture. And we started doing perform architectural katas, where you can watch me or my colleagues struggle with an architectural problem and actually have some result by the end of the session, and conversations with everyone involved. It's been very interesting doing these sessions, and the feedback is extremely good. So join us for one of these sessions. What do you think about all this? Do you have any questions or comments? Let us know in the comments. Have you ever used fitness functions? What are other questions you might have about defining architecture as a new architect or as an established architect? Maybe you have some experience with software architecture, but you still have some curiosities, questions, comments. Let us know in the comments. We love having comments and having conversations with you. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.